Dear students, so this is continued portion of determination of minimum expressions using essential prime implicants. So in the previous slides, we have seen how to solve a problem using essential prime implicants, and we determined certain as essential prime implicants and also prime implicants, and we have formed a minimum solution. So here let us take one more problem to determine the minimum expression using essential prime implicants. So now you have to know what is the essential prime implicant. So let us see the definition. If the given mean term and all of the ones adjacent to it are covered by a single term, then that term is an essential prime implicant. So here, if you consider this particular problem, you can see that if you see there is a mean term 1, is it? So this mean term has the adjacent ones. So you can see that it has adjacent 1 here, that is mean term 0, and also adjacent one more one you have, it is mean term 5. Okay, so here this particular term I am going to consider. Let me draw it in a highlighter. So if you are considering this mean term, and what are the adjacent ones to it, it has adjacent one here and also adjacent one here, is it? This one is an adjacent one, this is also an adjacent one. Okay, so it is covered by a single term. If you see one here, this one, it is covered by only one single term, that is a bar c bar. So we conclude that this a bar c bar is an essential prime implicant. Okay, so next thing, so we also have to know which are not essential prime implicants. So if all the ones adjacent to the given term are not covered by a single term, then there are two or more prime implicants which cover that mean term. And we cannot say whether these prime implicants are essential or not without checking the other mean terms. So what it means is, if suppose I am going to erase it. Okay. So if suppose here you are going to select the mean term 5. Okay, this mean term. So this mean term is covered by a prime implicant, that is a bar c bar, and also it is covered by one more mean term. So you have to check see this whether this prime implicant is essential or not. You have to conclude it, is it? Essential means it has to be covered by a single term, but here this M5 is covered by two terms, so you conclude that it is not a essential prime implicant. Okay, the thing is, what is the conclusion here is, if the given mean term is covered by only single term, then we say it as an essential prime implicant. If the mean term is covered by two or more prime implicants. So in this case, you can see that this mean term phi is covered by a bar c bar as well as this term. Okay, that is what is this term here? A bar, a bar b and b, a bar b, a bar bd. So this is the other term you are going to consider. So we conclude that since this one is one what you have considered is covered by two terms, we conclude that it is not a essential prime implicant. So you can understand this problem very clearly. So take this example here. So consider the mean term m0. What is m0? This m. So the adjacent ones of mean term m0 are m1, m2, this term, and M4. Okay. So now whatever I have considered here, mean term is M1. So because here no single term covers these four ones, no essential prime implicant is at apparent. So here actually what happened is M0 is covered by two terms. One is A bar C bar as well as A bar B bar D bar. It is not a prime essential prime implicant. Okay. The next term you consider. Next term, let us take one more term. For example, let us take M1 here. Okay. The adjacent ones for M1 are uh, M0 and M5. Is it? So the term which covers these three ones, that is, if you say this term and this. Okay. So this is A bar, C bar. So this is since it is covered by only single term, that is A bar, C bar. It is M1 is a essential prime implicant. Okay. So let me consider one more mean term, that is this term. Okay. The only one adjacent to M2 is this one. Is it? The only one adjacent to M2 is M0. Okay, so that's why A bar, B bar, D bar is also essential prime implicant. We conclude that that is a essential prime implicant. Okay, next thing, next neat term we are going to consider, that is, you can see this term. It is covered by only one single term. It's or no. The only one uh, adjacent adjacent one, that is adjacent to uh, M1, M11 is M15. That's why ACD is also a essential prime implicant. So there are two, you have found A bar C bar as a prime implicant, essential prime implicant, A bar B bar D bar as a essential prime implicant, ACD also as a essential prime implicant. Since it is covered by only single term. Okay, what is the term here? ACD, A bar B bar D bar, and also A bar C bar. Here in this case we have selected this term. In here in this case we have taken M2 to explain essential mean term, and next here M11 as a mean term to select the essential prime implicant, that is ACD. So till here we have found the three essential prime implicants. So if you see here, the main three essential prime implicants are A bar C bar, A bar B bar D bar, and ACD. But do you think this is a final expression? You have covered four terms here, is it? Okay, four ones here, done. And A bar C D you have encircled. This term also got encircled, but remaining ones you have here, is it? This if you see here, M7 is not covered, not yet covered, is it? So which, where to include this one, whether to include for this or this? So there is, so till whatever you have got, A bar C bar and A bar B bar D bar and A C D is the essential prime implicant, but one more this what do you say, sorry, A bar C bar, A bar C bar, A bar B bar D bar, A C D are essential prime implicants, but one more prime implicant is present to complete the solution. So here If you see, there are two possibilities. So you can include this one into a bar c bar, or you can include this one to a c d. So the final expression will be either is a bar c bar plus a bar b bar d bar plus a c d plus a bar b d. Okay, so this can be one expression, or else another expression is also possible, that is a bar c bar plus a bar b bar d bar plus a c d plus b c d. So there are possibility of two expressions. Okay, if the students write this particular expression, if I say this expression, okay, that is also right. Or another uh, student can write expression, that is a bar c bar plus a bar b bar d bar plus a c d plus b c d. So that is also right expression. Okay, but you need to cover all once to make a final expression. So here this is a bar c bar is a essential prime implicant, a bar b bar d bar is a essential prime implicant, a c d is also essential prime implicant, but a bar b d and b c d is a non-essential prime implicant, but it has to be included in the expression, final expression. So to complete the what they say here is, complete the minimum solution, one of the non-essential prime implicants is needed. So either A bar BD or BCD may be selected. So the procedure that can be used to obtain a minimum sum of products from a K map are, so what you have to do is, first you have to choose a mean term. For example, A1, which has not yet been covered. So that you have done in the previous problem. So you can choose any mean term uh, which is uh, which is not yet been covered. That means sometimes you may have found in the previous problem, if you have done, you have chosen a bar c bar as a essential prime implicant, and in the next step again no need of choosing the same mean term, for example m1, to include a bar c bar. Okay, so you have to include a new term. So that is what they want to say, choose a mean term which has not yet been covered. Okay, the next step is find all ones and x adjacent to that mean term. So if you say x means, here it is a don't take condition, x can take either 0 or 1. So usually we consider x as 1 to using when you are solving the k maps, is it? So everywhere you have solved the problem and you have encircled ones. So x can always take uh, 1 in that case. So here find all ones and x adjacent to that particular mean term. Okay, and what next you can do? If a single term covers the mean term and all of the adjacent ones and x, then that term is essential prime implicant. So select that term. So that you have done already. So if a single term is covered by the mean term and all adjacent ones and x, then that term is an essential prime implicant. Note that don't get terms are treated like once in the step 2 uh, and in step 3 but not in step 1. Okay. Okay. So next thing is, repeat step 1, 2 and 3 until all essential prime implicants have been chosen. You have to cover all the terms and you have to find the essential prime implicants in your problem. What else you can do? Find a minimum set of prime implicants which cover the remaining ones on the map. If there are more than one such set, choose a set which with a minimum number of literals. So in the previous problem, as you have seen, there were two possibilities that to include. That is, if you would have chosen A bar B D or B C D. So in this case, the literals are same in number, because there are three literals in that case, that problem. Okay, sometimes what happens, you may have end up with the different uh, expressions, and you get the number of literals. Maybe in one term you may get three, and in another term it may be two. So in that case, you have to choose which has the least liter. Okay, if it is having in that case two liters, you have to choose that liter, is it? So in your previous problem, you have seen solve the problem, right? So in that case, there was no confusion, because the term which was not an essential prime implicate, it had got same number of literals. That was number of literals were 3. So there was no confusion to choose which term. Okay, you can choose either A bar B D or B C D. So that is the last step you have to do in your determination of minimum expression using essential prime implicate. So the procedure for getting the minimum expression is already explained. You can follow this flow chart for this procedure. So if they ask in exam, write the flow chart, then you can explain that. So what they have to do, choose A1, or A1 is in the sense you have to choose a mean term which has not been covered. Okay, that is the first step. Then the next step is find all adjacent ones and x. Okay, if there is a don't care conditions, then x has to be considered as ones, or else you can if you don't have don't care conditions in your problem, you can leave this thing. Okay, only you have to find all adjacent ones. So that will be the second step. And next step is, there is are chosen one and its adjacent ones and x covered by a single term, that you have to find. So this is the main step here in the procedure, because you have to see whether it is covered by a single term. Whatever the mean term you have chosen, whether it is covered by a single term, that you have to see. If yes, then the term is an essential prime implicant. If not, what happens? Okay, if not, you have to leave that particular step. You should not consider that term as an essential prime implicant. Okay, you have to leave that term. Okay, if it is covered by two expressions or two terms, if the mean term is covered by two terms, then you have to leave this uh, leave this particular step. If it has, or if it is covered by single term, then you have to go for choosing that term as a essential prime implicant. And next step is all uncovered ones are being checked. Okay, if other terms are the if you have follow the procedure, and if you have found all the essential prime implicants, you will be stopping the procedure. If not, you have to check for other ones also in your problem. Okay, and next step, what you can do, if all uncovered ones are being checked, then find the minimum set of prime implicants which cover the remaining ones on the map. So finally, what you have to do is find the minimum set of prime implicants. So in the previous problem, you have found three essential prime implicant, and the other last term was the non-essential essential prime implicant. So finally, you have found the final expression. Okay. And if you have not covered all ones, that means if some mean terms you have left to check, then you have to go for the previous step again. That means again choose the one which has not been covered. That same step has to be repeated until all ones are covered. Okay, then stop the procedure, that is determination of minimum expressions. So finally what you have to do, finally note that here all essential prime implicants have been determined at this particular point. So only after covering almost all the ones and you have found the essential prime implicant, you'll be able to determine the minimum expression. So at this particular point, you have to cover or you have found all the essential prime implicants. Okay. So next thing is finally you'll be writing the expression whatever you want. That means you have selected, if you have selected three essential prime implicant, that all three essential prime implicant you will be writing in the solution. Okay. So then stop the procedure.